Okay, here's our quick notes on acid-base chemistry. First thing, acid and bases. If you want, you can watch a little video on that on YouTube called Acid and Bases for Kids. It's a great introduction. So acids taste sour, bases taste bitter. Acids and bases both look like water. Acids feel like water, but bases feel slippery. They both are corrosive to humans, and they both are electrolytes. And we need to know that all acids and bases are done in solution. So we should assume all aqueous solutions for this. Okay. As we define acids, they are going to be compounds that contain hydrogen 1 plus ions, and we'll always see hydrogen written first in the formula, and there are 3 examples for you. Bases are compounds that contain hydroxide ions with one exception of ammonia. In the blue box, we see that ammonia creates hydroxide when it's added to water. So that is why it can be a base even though it does not contain hydroxide ions. The hydroxide will always be written last in the formula, and there are 3 examples for you there too. Water is also considered an acid and a base at the same time, because if you look at water, it's H2O, or we can write as HOH, meaning there's hydrogen ions and hydroxide ions. So because there's equal amounts of both, they cancel out and makes water neutral. The way we measure how acidic something is or how basic something is basically a relationship of how far away it is from water's neutral point, and we use the pH scale for that. The pH scale is a 0 to 14 scale, as you see here. And if you look at it, 7 is our neutral point, that's in the middle, that would be water. Anything greater than 7 up to 14 is going to be a base, anything less than 7 down to 0 is an acid. And the further we get away from that 7 point, the more concentrated that acid or base is, and also relates to how corrosive or how dangerous that acid or base is. When we determine pH, we have different tests. Litmus paper will turn red. If it is in an acid, it will turn blue if it is in a base. pH paper has a range of colors that you can match up with a number scale. Indicator solutions give you different colors as you drip them into that. The one that we need to be aware of or know is phenolphthalein, the second from the bottom. That's clear in an acid and pink in a base. And of course, there are pH meters that we have also. pH meters are more precise, but they also are more expensive and harder to maintain, so that they're not always preferred to use. When acids and bases react with each other, they create what's called a neutralization, or they cancel each other out. One of the things we make from that is a salt, which is basically an ionic compound. Okay, we call them a neutralization reaction because they make a neutral pH. So if we see 3 examples down here of an acid and base reacting, you'll notice how every time they make some sort of ionic compound, and then they also make water, which ends up being neutral. To do these neutralization reactions, we do a process called a titration, which is a lab technique that measures how much base it takes to neutralize an acid. Okay, that tube that's used is called a burette, and it's very accurate. Okay, we do need to use an indicator solution, which we will use phenolphthalein for that, which of course is going to be pink as soon as we make it a base, and it will be clear in an acid. Now, if you do spill an acid or base, there are some rules for cleaning them up. We want to avoid skin burns and anything that can actually hurt our bodies. So to do that, if you spill an acid, you want to use baking soda, which is a weak, safe base to clean it up. Okay, so things like battery acid, concrete etcher, toilet bowl cleaners, aluminum cleaners, those are kind of things you may spill around your house that you'd probably want to neutralize with a base before you clean them up. A base spill, we want to use vinegar to clean it up. That's a safe, weak acid. So things like bleach, toilet bowl cleaners, concrete, lye, those kind of things that you may have in your house can cause it too. Now, concrete when it's dry is safe, but concrete when it's wet can cause base burns too. One thing we don't ever want to do is mix toilet bowl cleaners, because some of them are based on hydrochloric acid, which is a really strong acid. Some are bleach-based. If you mix bleach and hydrochloric acid together, you can get a very toxic and actually deadly gas that contains chlorine, and chlorine gas can actually kill a person if they breathe in too much of it. So make sure that if you're doing anything with bathroom cleaners that you double check that you're not mixing any cleaners that contain both the hydrochloric acid and the bleach.